Hello guys, we are again back with one of the new concept of our operating system, which is the process types. In today's lecture we are going to cover the process types, which is cooperative versus independent, interactive versus batch process, and input output bound versus CPU bound. We also try to discover or try to cover the CPU scheduler algorithms. Okay, first of all let's discuss the process types. So first our concern is about the cooperating versus independent. In cooperating process, the cooperating process can affect or be affected by the execution of the another process, and in independent process, the independent process, as its name shows, it is independent, it is not dependent, so it's not used or it cannot be affected by the execution of another process. Next, interactive versus batch process. Interactive means foreground, which can be seen by the user, and background or batch, which can't be seen by the user. Or in interactive or foreground, the user interact with the user during execution with the process, and in batch, the user doesn't interact with the process. Input output bound versus CPU. As its name shows, input it includes the input output. I spend more times doing the input output than computations, and many short CPU bursts. And CPU bound processes spend more time doing the computations and few very long CPU bursts. As I told you earlier that we are also discuss the CPU scheduling algorithms. So we have one algorithm, CPU scheduling algorithm. In these algorithms, first of all we have fcfs, then shortest path first, okay, then srftp, then priority scheduling, round robin, multi-level queue, and multi-level feedback queue. It is the algorithm which is used by the CPU scheduling. So what is the criteria, what is the best criteria to check the algorithm? So for the criteria for we are going to discuss the criteria which is used to check the best algorithms. So first of all we have to keep in mind or keep in view the CPU utilization, the throughput time, the waiting time, response time, and turnaround time. So CPU become idle in three cases: when the process is terminated, when the input or output is interrupt, or when the time counts end. So our motive is to keep the CPU always busy. When CPU is always busy, then the algorithm goes very smoothly, or it's the best one. CPU scheduling algorithms. First of all, we have the permittive and non-permittive. We have two groups, permittive and non-permittive. First, let's discuss about the fcss. So fcss means first come first serve. It is the non-permittive. So here is the table when the which include the processes, its arrival time, and burst time. In table, our processes is given, their arrival time is given, and the burst time is given. Let's make a Gantt chart. Process 1, its arrival time is 0, and its burst time is 24. From 24, P2 is started, and after P2 we add the 3, which is the burst time, 3 into the P3, which is going to 27. So process time is 0, burst time is 4. So waiting time, we have waiting time for the process 1 is 0, waiting time for the process 2 is 24, and waiting time for the process 3 is 27. Let's add all these. After that we have the turnaround time. In turnaround time we have 24 for the process 1, 27 for the process 2, and 30 for the process 3. After adding up all these, we have average waiting time 51, which is the total divided by how number of the processes divided by 3 equals to 7, and average time around time is 81, which is divided by 3 equals to 27.